It's just being played by my computer. I mean, nothing's changed except that Streamlabs had an update the other day. I mean, I've done everything. I have no idea why it's doing this. Because my voice isn't messed up. It's changed except that Streamlabs had a Yeah, my voice is fine, so why would the audio output be messed up? Yeah. I mean, I've been streaming on um this M1 Mac for over a year. But wait, is that regular OBS or is that Streamlabs OBS, the native beta? Because I'm using Streamlabs OBS. Yeah, I'm not set up for regular OBS. The only reason I switched to Streamlabs is so that I could easily stream to YouTube and Twitch at the same time. I like the regular original OBS. Can I send? I'm not sure. I wonder if I could send the music audio into this Elgato. Um, let's see what happens with that. I'm gonna open Logic and see if this works that way. I can't hear that. Can y'all hear that? Is it distorted? Let me check it out. Let me pull it up on my phone. Let me check it out. Let me pull it up on my phone. Oh no, that's what it sounds like. That's right. That's what that beat sounds like. Now the question is, why can't I hear it? Multi-output device. Sound. Why can't I hear this? This makes no sense. I guess I could do that, but then I have to hear my voice. Check. Can you still hear my voice? Check, check. Can you hear my voice? Okay. All right. So I guess I'm a big dum-dum and I should have just been using this wavelength software for all the audio in the first place. Okay. So all right, so where was I? Oh, I guess let's just check out the way the plugin sounds right now. Okay, so I got input and output. You can mix each band between being affected by the Bit Crusher or not. So okay, so we got 4 bands and right now they're all in, so this just should basically affect the entire output. So let's check it out. We got a bit depth and a resample. Oh, I guess something's messed up with the audio. Let's see. I did just make a few changes. Oh, and while I'm here, can I make another one for like I don't know what the music is technically playing through. Not Finder. Is it playing through QuickTime? Or Stream Deck? Okay, yeah. Okay, how's the music sound right there? Okay. It's not too loud, is it? All right, cool. All right, so I set the cutoff. Actually, hold up. We can take that out of update. Oh no, we'll leave it in update parameters. That's fine. Let's see. I did do this, so I put normal process block, input block, that. Let's put this back right here. I wonder if something I did messed it up. Let's just see. Oh, I need a block. Let's see here. That'll work. Oh, let me make the code bigger too. Why is this taking so long? Oh, it's a release build. The builds won't take this long after this. All right, finally. All right. Let's put that in there. See if it actually runs. Did I do something? Oh, yeah. Yeah. All right. That should be good now. So I'll show you what it sounds like, and then we can kind of talk about the DSP a little bit. What does buzz mean? Oh, really? Oh, I see. Yeah, I'm just gonna leave it off. I don't know why it's being so weird. All right. The plugin should work now. Okay, cool. So there's our basic sound. So let's do the bit depth first. So at 5 bits, that's where it starts sounding real cool. And then so what we can do is we can take the low band out of that. So we should, if we turn this down, we should hear the bass unaffected. Yeah. So you can still kind of hear it in the high end. And we could take the high end out. And now it's kind of just in the mid-range. And now it's just kind of in the low mid. Now there's nothing. And we could put it back in just the low. Which sounds cool. Okay, then let's do the resample. This will be the classic kind of... I mean, that's it. Resample sound. Oh, but it's loud. I wonder why it's getting louder. Oh, it sounds kind of cool with just the low band. So if we go back, we can also mute a band. So there's band 1, the low. And then here's the high. So the other cool thing would be to add a solo button where it'll turn all of them off except for the one you soloed. We also have a weird drive that I made. Yeah, it's kind of subtle. And the reason I did that was because when you put it on something that's kind of melodic, it changes the pitch, but that might not necessarily be a bad thing. So if we go look at it, this is it right here. So what I normally do is, so this is based off of a half-wave rectifier. So what I came up with actually this, doing multiplying the positive signal between 1 and -1, and you get a really cool like lo-fi distortion sound. Let's just build it real quick and I'll show you. But when I tried it out on a melodic loop, it was kind of changing the pitch. Like it was adding harmonics that actually were, I guess, so apparent that they actually sounded like another pitch, and it was making like dyads, but then it started to get out of tune. So it was kind of weird. I'll show you. Let's see. So it's actually really cool sounding, especially on drums. But if we go to a melodic setting right here, let's see, make sure all this is off. So check out when I move the drive. It's adding some weird harmonics. Which, I mean, it's cool. I mean, if you want, like, all the way up will sound good on, like, percussion, and then if it's too much, you can just turn it down. And do I have anything? Is the master mix doing anything? No. So it's really the lows that affect this drive the most. It's strange. Yeah, it's not intentional, that's just kind of how it is. So sometimes you kind of do some happy accidents in DSP. Let's see, does it make sense now to have a complete master mix? Because like right now what we're doing is, okay, so you see how each little section is 4 lines? So imagine there's only one of each, and that's kind of like what the basic DSP is. So imagine low band is your signal. So we're multiplying it by half and then adding 0.5. We're getting the total Q levels. That's the bit depth, and I'm actually setting that in the bit depth setter method so that it's not running every sample because it doesn't need to. We can just set it whenever the bit depth changes and then leave it. That saves a little bit of CPU. And then we round the wet signal, or the signal. Then we round it and do a little bit of math. This all comes from the Hack Audio book, by the way. So yeah. Then we do the slow F mod with the signal, and we subtract out this remainder. We do our little rate divide thing, which is the resampling. And you can see right here, it's going back in the samples and pulling out whichever one that matches. And this is the distortion. And here's the mixing for each one. Now, if we have a master mix, that would basically just be if we have a master mix, it would basically act as a macro for all 4 of these, maybe. Because if we say, like, we do our mix logic here for each band, and then what if we do it again as a master mix? What would that even be? That would be, oh, that would be, okay, you know what it would look like? It would look like this. Do I have a master mix variable? Yes, mix. Okay, and then do I have something setting it? Master mix, yeah, mix, okay. So if we do this, we go right here and we say 1 minus mix dot get next value. Okay. Times our dry signal, which is yeah, data sample. Okay. So if we take this, we do it right here, and then we add all of these together times mix. That will mix it together. And I don't know if it'll be super useful, but we can see what it sounds like. Am I setting it in the update parameter? Rotor set master mix. Yes. Okay, so let's see if it does anything. And by the way, if you download the Viator DSP repo, I put in this brick wall low pass filter. So it's basically 6 filters, 3 for the left, 3 for the right, and they are just making a really steep low pass, and it's wrapped in the JUCE SIMD register stuff so that it processes interleaved samples. So it's like, I think it's processing like either 4 or 8 samples at a time in parallel. Because before this, it was using a whole bunch of CPU and now it uses less, which is nice. So I added that. We've got the multi-band processor that I put in there. It's pretty easy to use. You just um, you give it an input, you call process sample, and then you can call get each band. Oh, thanks for the follow, Gatton Noob. Let's see. It built. Let's check it out. All right. So now, I assume. Oh. So yeah, I think it's working. Yeah, it's working. Okay. So resample is getting louder, and I have a hunch. So I think when I added all this quadruple processing, what signal low is data sample? Okay, I think I should multiply each one of these by 0.25 so that all four of them add up to 1, right? Because I'm taking the yeah, so we're taking the yeah, so we're taking what's in the channel sample loop. So yeah, we're taking like the full input. You know what? Is that messing up our mix logic? That might be messing up our mix logic. We might have to rearrange this because you're basing this off of what's originally in the buffer, not what you're getting now. So we might have to put this first. Yeah, I'm not sure. Let's see. Let's just see if this fixed our increased volume problem. Yeah. Okay, it's actually, it seems like it's not really affecting our mix logic, but it seems like it would. Because data sample blah 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 is not does not contain any of this, right? That's what's originally in the buffer. So we might have to what if we do this? What if we do Hmm. Okay, I got an idea. Okay, so I kind of feel like we should. This needs to be first. Um, and then what we'll do is say channel data. Is equal to that, so that channel data now equals our resample thing, and then after that, the multiband processor actually splits up that. I'm not sure if it'll drastically change the sound, but I think it makes more sense now. Because whenever you gotta think about this as whenever you say like data equals something, you're replacing what's in the buffer. So now whatever uses data sample after will have whatever you updated it to. So I think that makes more sense. And I guess this will help us a tiny bit on CPU because now we just have one expression. It's probably not gonna make a big difference, but it's something. It ain't much, but it's honest work. All right, let's see what it sounds like. Well, that sounds terrible. I think yeah, that sounded, even though it seems like it makes sense, it just sounded bad. So don't, I wouldn't sacrifice a cool sound quality you have just to make it technically correct. Let's make sure it's back. Yeah. Okay, so let's see. Let's see if input and output is working. So let's turn the drive up. Let's see. Oh, wait. I forgot that I moved stuff out of the process block because I thought that was the issue, but we figured out that it was something in the uh the class. So let's put this back in normal process. Oh, it's already there. Okay, so we just call normal process block on buffer. And that should give us our signal chain. So we've got the input gain, our marauder effect, output gain, phase invert if we need it, and then hard clipping the output. So let's see what that sounds like. I keep forgetting. I want to make sure that the master mix defaults at 1 instead of 0. Okay, so here's our distortion. Yep. And sorry, hard clipper might not be clipping at the right level. Let's check that out. That is in Viator Utils. So what am I doing? Let's see. We're hard clipping the block. So we'll go to Utils. Hard clip block. Let's do decibels. So let's clip it to negative 0.1, kind of like what people do with limiters. And I'm wondering, this copy sign is supposed to be faster, but I don't know if it's actually working. Let's see. And I think we might want to make a button for the hard clip, because some people might want to be able to gain stage after. And I guess you could get into a situation where even though, I don't know. Because if you turn the output way up, it shouldn't clip. No, it should be fine, because if it goes above 0, it'll be clipping anyway. So yeah. So let's see. Let's see if it's actually clipping at negative 0.1. It's at 0. So I'm thinking I'm gonna go back to my, even though this is a little faster and more efficient, what I'm gonna do is data sample times equals 1 divided by oh wait, times equals I think it's 0. No. What am I doing? This number right here divided by this. Button to, oh, I hear my voice all of a sudden. Check. Okay. What was I saying? Oh yeah, Stream Deck. Having the button to turn my voice on and off so I don't have to cough into the microphone is real nice. Didn't even notice. Did it build? Yeah, okay. All right. Are we finally getting clipping? We don't actually have to turn the mix up for the clipping to work. Oh, it's still, I guess it might actually just be logic. So okay, so let's go back to the way it was a second ago, like this. This is probably working, but I bet whatever this is, so that would be let's see, 10 raised to negative 0.1 divided by 20, 0.9885. So yeah, so it's probably working. It's just logic is probably just rounding the value that it shows you because it's so close. So that should probably be fine. So we can leave it like that. Yeah, so cool. So we've got the input, the filtering, and the resampling, and then okay, so is there anything else I wanted to add? We need to also be able to solo the bands. So let's see if we can figure out how to do that. It might be, let's see. Okay, so it would probably, is there a better audio meter plugin you could put after yours in the chain? Oh yeah, actually, I mean, there's, yeah, we could try that. Logic's built in, got a couple of other built-in meters that are probably better. Let's see. I didn't even think about that. All right, let's see what we've got here. Loudness. Oh, that's loves. Does this one have any other options? Let's see, what's the other one? We could do the multimeter. Is the multimeter the one I'm thinking of? Yeah, look, peak is negative 0.1. That was kind of small for y'all, but yeah, looks like it's working. The left and right peak is negative 0.1. Our correlation is good too. So yeah, we should be good. And what I was just thinking is that our solo logic, we already have these right here, band 1, 2, 3, and 4, and these are the toggles. So instead of making more audio parameters, it'll probably make sense to just have the on-screen solo buttons not actually be linked to the audio and just have them turn these on and off instead of actually tracking them as parameters. Probably be fine. Yeah, so adding a some kind of EQ to this probably wouldn't be a bad idea. Let's see what our CPU usage is like. So let's build as a release so that we get a good idea of our CPU usage, and then we'll test it in Reaper because I feel like Reaper's CPU metering is way more accurate than Logic. Logic seems to kind of peak for no reason. Like the meter, like it runs fine. It's just sometimes, I don't know, it's just weird. We could add maybe a actually, yeah, that would probably be good. Just a low pass and high pass would probably be enough. We probably don't need like a band peak EQ or something. Unless, I mean, it's not like it's hard to add it in, so we might as well. Because the filters that, you know, the Viator DSP filter is, it's not very heavy on CPU, so we could just add some. It doesn't really, it won't really make that big of a hit. One thing that would be nice would be to SIMD wrap the multiband processor filter thing, because that's kind of a decent CPU hit. I don't know if you can like the SIMD stuff is hard. Like the only reason I got it to work was from a JUCE tutorial on the JUCE website, and I don't really understand it that well. Um, but I know that it won't work for any class because the SIMD instructions only include certain operations like plus, minus, multiply, divide. If you're doing any like I don't think there's like tan, atan, cosine, stuff like that. So if you have a class that uses any math that isn't involved in or isn't available in the SIMD, then it won't work. In fact, we could take a look real quick. Yeah. So if we go to DSP, SIMD register. Well, that's element access. Is there another? Yeah, SIMD register. Okay, so we've got get set operator. Okay, so we've got plus, minus, multiply equals bit and oh really? SIMD? Wow, I'm dumb. Okay, thanks. So if you do something mathematically in the DSP that isn't in these options, the SIMD won't it won't build. You've got absolute. So it might be a good exercise to try to convert my distortion classes to SIMD. Um, yeah, that would be good. All right, so this finished. Let's go check it out in Reaper and see what we've got. Marauder. Following plugin could not be loaded. That's pretty cool. Oh, what? Did I not move it? Let's see. I don't really use Reaper that much. Where's the rescan? What? No, that's been around for a while. All right, here we go. Because SIMD isn't JUCE related. I mean that's processor related, so that's probably been in there for quite a while. All right, our CPU usage is 0.3, which is pretty good. Because if we remove it and we do something like if we check out BOD, which everybody loves, this is a great SansAmp model. It uses 0.4, 0.5, 0.6. And then we got the Tube Screamer, which uses a little bit more. .3, it's not bad at all. 1.4. I think where you really start getting into like trouble is like, you know, well, in Reaper it seems like 6 would be like starting to get really high. So if we go to something that I know uses a lot of CPU like neural. Yeah, so this one's using 3.5, so you definitely shouldn't be using more CPU than a neural amp. So I think we are fine. We can start adding some filters. And before I wrapped the what's it called, the brick wall filter in the SIMD, the CPU usage was at like 6, something crazy like that. So yeah, let's add some filters and let's get rid of the let's not do debug. I mean, let's not do release because I'm gonna get mad that it takes forever. Let's just add some a low pass and a high pass for now, and then call that a day. For now, so we will we'll put it outside of. We don't need to put it inside of that class. We can just use one out here. So let's see. Yeah, we're just gonna use a Viator one. So let's go here and say Viator DSP, and we'll say what's it called? Filter, SV filter. And while we're at it, we need to go into the parameters and make some new parameters. So we need 2 of them. What does it call it? Low pass and HP. And you can leave the extern keyword in the C++ file, no problem. So let's see, this is gonna be low pass and low pass and high pass and high pass. Okay, go into here. We'll probably add some kind of EQ, so let's just make another little comment section right here. So like that, and also remove it. And take 2 of these. Let's see, LP. HP. Then we'll make some parameters right here. We'll do something similar. We'll say filter range. Or let's just say pass filter range. This is going to be from 20 to 20K. Yeah, and then we will say pass filter range equal to pass filter range dot set skew for center, and we'll put 1000 in the center. Oh wait, we don't need to do equals, just do like that. Okay, and then we need two pushbacks into the parameter vector. And it's going to be pass filter range. Okay. And that is it. We need to prepare those filters and also set up their initial state, which needs to be kind of specific. So I usually go into something like, I think my distortion uses filter. Yeah. So yeah, just take this and bring it over here. This is called LP filter, I think. And then put the cutoff in update parameter. So this will be LP ID. Then we'll do the same thing for the high pass. High pass. We need to prepare the other one. So let's take that. And we need to change the type to high pass. And now that I'm thinking about it, we need to make sure that the initial values are correct. So low pass, which is high cut, should be 20,000. And then high pass should be 20. Cool. And I guess we could put a button on each one that's going to be like pre or post so that you can choose which way you want it. So let's just put it after for now. Okay, let's see if that works. And that is taking forever. Nope, it's debug. Oh, we haven't built it since we switched back to debug, probably. Hey, what's up? Man, this build is taking forever. Cool. Check that in plugin doctor. That'll just be easy to make sure that it's actually working. So this is Marauder. Looks like it's not working. Oh, there it goes. Okay. So let's see, high pass. Not working. Oh, it is working. It's just being slow. Let's check it out in Logic and make sure there's no weird latency or something. It might just be plugin doctor being slow. Seems fine. Okay, that should be good. Oh, that was Logic Pro. Oh, that's plugin doctor. So if you I have a feeling it's just being slow because Marauder is probably using a bunch of CPU in debug mode. If we get rid of it and we go to like BOD or something. Yeah, let's do BOD. So you have a linear view so you can see what the plugin is doing to the frequency range. So it looks like a normal kind of EQ analyzer. So if you change the lows, you know, the highs, blend, whatever. You also have an oscilloscope so you can see what it's doing to the wave. So like if this wasn't on, it'd be a sine wave, and you can turn the plugin on and you can see what it does to the wave. So it's pretty useful, pretty cool. You've got other things. You can check the you can change the sine wave frequency. You can, if we go to linear analysis, you can see the phase response. You could also do white noise if you want. You got harmonic analysis, which is cool. You got hammer sign. I don't remember what that is, to be honest with you. This is cool, little dynamics meter. Shows you what's going on. Performance. Yeah, I think this is like $30. So it's pretty cool if you're making stuff. To make sure like your filter cutoffs and stuff like that are actually accurate. So that's really cool. Yeah, it's awesome. And it's really well made. It's very consistent, very robust, very good. Let's see. I want to also add an EQ of some kind. Maybe like a low, mid, high. And pre and post button for the low pass, high pass, and EQ section. Anything else? I'll probably just do that on my own, and then maybe on the next stream we can start working on the UI. I'll have to really think hard about the UI and come up with a good look and be prepared before starting making it, because you know, if I don't think about it until I start making it, it's not going to come out as good. So I have to draw a couple of sketches by hand, see what works well, you know, how many parameters we actually have, stuff like that. But yeah, I think that's going to do it for me today. Thanks for watching, y'all. Go join the Discords if you're not in the Discord. It's in the Twitch about page. Yeah, love to see you in there. And I'm not going to do the outro music since it's probably going to be distorted like it was in the beginning. So